Good morning, friends. Now I am going to discuss about multimodal AI. Multimodal AI refers to machine learning models which is capable of processing and integrating information from multiple modalities or types of data. These modalities can include text, images, audio, video, and other forms of sensory input. Unlike traditional AI models that are typically designed to handle a single type of data, multimodal AI combines and analyzes different forms of data input to achieve a more comprehensive understanding and generate more robust output. As an example, a multimodal model can receive a photo of landscape as an input and generate a written summary of that place characteristic, or it could receive a written summary of a landscape and generate an image description based on the description. And this is the ability to work across multiple modalities give these models powerful capabilities. OpenAI launched ChatGPT in November 2022, which quickly put generative AI on the map. ChatGPT was unimodal AI designed to receive text inputs and generate text outputs by using natural language processing. Multimodal AI makes generative AI more robust and useful by allowing multiple types of input and output. DALL-E, for example, was OpenAI's initial multimodal implementation of its GPT model, but GPT-4o introduced multimodal capabilities to ChatGPT as well. Multimodal AI models can combine information from various data sources and across media to provide a more comprehensive and nuanced understanding of the data. This allows the AI to make better informed decisions and generate more accurate outputs. By leveraging different modalities, multimodal AI systems can achieve higher accuracy and robustness in tasks such as image recognition, language translation, and speech recognition. The integration of different type of data can help in capturing more context and reducing ambiguities. Multimodal AI systems are more resilient to noise and missing data. If one modality is unreliable or unavailable, the system can rely on other modalities to maintain performance. Multimodal AI enhances human computer interaction by enabling more natural and intuitive interfaces for better user experiences. For instance, virtual assistants can understand and respond to both voice commands and visual cues, making interactions smoother and more efficient. Imagine a chatbot can talk to you about your glasses and make sizing recommendations based on your photo that you share with it, or a bird identification app that recognizes images of a particular bird and confirm its identification by listening to an audio clip of its song. AI that can operate across multiple sensory dimensions can give users more meaningful outputs and more ways to engage with the data. How multimodal AI works? AI is a rapidly evolving field in which latest advances in training algorithms to build foundation models are being applied to multimodal research. In this disciplines are prior multimodal innovations such as audio-visual speech recognition and multimedia content indexing, which had developed before advances in deep learning and data science paved the way for generative AI. Gen AI. Today, practitioners uses multimodal AI in all kinds of use cases, from analyzing medical images in healthcare to using computer vision alongside with other sensory inputs in AI-powered autonomous vehicles. A 2022 paper out of Carnegie Mellon describes the characteristic of multimodal AI: heterogeneity, connections, and interactions. Heterogeneity refers to diverse qualities, structures, and representation of modalities. A text description of an event will be fundamentally different in quality, structure, and representation from a photograph of the same event. Connections refers to the complementary information shared between different modalities. These connections may be reflected in statistical similarities or in semantic correspondence. Lastly, interactions refers to how different modalities interact when they are brought together. The core engineering challenge for multimodal AI lies in effectively integrating and processing diverse type of data to create models that can leverage the strength of each modality while overcoming their individual limitations. The paper's author also put forth several challenges: representation, alignment, reasoning, generation, transference, and quantification. Representation refers to how to represent and summarize multimodal data to reflect the heterogeneity and interconnections between the modalities. Practitioners use specialized neural networks, for example, convolutional neural network for images, transformers for text. Convolutional neural networks for images, transformers for text, to extract the features and to employ the joint embeddings and employ joint embedding spaces or attention mechanisms for representation learning. Alignment aims to identify connections and interactions across elements. For examples, engineers uses techniques for temporal alignment in video and audio data, spatial alignment for images and text. Reasoning aims to compose knowledge for multimodal evidences, usually through multiple inferential steps. Generation involves learning a generative process to produce a raw modalities that reflect cross-modal interactions, structures, and coherence. Transference aims to transfer knowledge between modalities. Advanced transfer learning techniques and shared embedding spaces allow knowledge to be transferred across modalities. Quantification involves empirical and theoretical studies to understand multimodal learning to better evaluate their performance within multimodal models. Multimodal models add a layer of complexity to large language models, which are based on transformers themselves built on an encoder architecture with an attention mechanism to efficiently process data. Multimodal AI uses data fusion techniques to integrate different modalities. This fusion can be described as early when modalities are encoded into the model to create a common representation space. Mid when modalities are combined at different pre-processing stages, and late when multiple model process different modalities and combine the output. Trends in multimodal AI. Multimodal AI is a rapidly evolving field with several key trends shaping its development and application. Here are some of the notable trends. Unified models. OpenAI's GPT-4 Vision, Google Gemini, and other unified models were designed to handle text, images, and other data types within a single architecture. These models can understand and generate multimodal content seamlessly. Advanced attention mechanisms and transformers are being used to better align and fuse data from different formats, leading to more coherent and contextually accurate outputs. இது வந்து enhanced cross-modal interaction. Real-time multimodal processing, application in autonomous driving and augmented reality. For example, triggers AI to process and integrate data from various sensors, cameras, LiDAR, and more in real time to make instantaneous decisions. Multimodal data augmentation. Researchers are generating synthetic data that combines various modalities to augment training data sets and improve model performance. Open source and collaboration. Initiatives like Hugging Face and Google AI are providing open source AI tools, fostering a collaborative environment for researchers and developers to advance the field. Thank you, friends.